Okay. Well, hello everyone. I hope more people will start joining us in the next few minutes. At least that would be nice because it's a little empty now. First, let me explain who I am, who I represent, and what I'll be talking about here today. My name is Jaron Vietor. I'm the CTO for DDVTech. We're a tech startup right here in the Netherlands. And the product that we've developed is MistServer. And as you can see, the text says next generation multi-standard media streaming server. And you might be wondering what that actually means. Well, I'll be getting to that later, but first I would like to explain why we went and set out and started this project. I am the CTO, so I'm a technical guy, but I'll try to keep the presentation mostly accessible for the non-technical people also. Alright, so first of all, why did we do this? The reason we started this project is because we were trying to make something that needed a media server ourselves. And we noticed that the existing solutions don't really have a good way to control your server, nor to get feedback about what is happening in there. Additionally, we found that all the existing solutions are very closed, as in you can't figure out how it works, nor are you able to add your own extensions to it, or is it able to make modifications to what is already in there. Additionally, the existing solutions are not really very efficient or lean, and with lean I mean that they are big bulky projects. It's not uncommon for a media server to be several hundred megabytes big. So why are these important? Because they're already in use, pretty widespread, and nobody seems to have any problem with these limitations. Well, I outlined some of the reasons why this is important in the same order as I listed the things that we think are not okay with them right now. We need control and feedback to be able to scale up and down. Let me explain how why that reasoning is like that. In order to scale, it's nice to have the same server and be able to just copy it and have extras that you can turn on and off as needed. In order to set this up properly, you'll have to automatically send configuration in there. You'll have to be able to set them up, configure them, get information about how the usage is, and then when they're no longer needed, you need to be able to tear them down and reconfigure the rest to handle the load again. And this is not possible if you're not able to control the server very finely, as well as get information about what is happening in there. So that's why we needed those. So why is it not good to have open extendable solutions? Being open, and in our case that actually means open source, helps maintain compliancy to standards, because people will notice when something's not compliant and they will send in patches to help alleviate the problem. Additionally, of course, this brings flexibility because you can simply add your own part and you don't have to ask anyone. You can just go ahead and write it and you can put it in there and it will work. And it also helps maintain a secure product as well as a stable product, because everyone will be watching in your code and checking if everything is correct, and will point out when it's not. And that's not something that happens with closed products. So that's been an advantage that we think we have. Now the efficiency leanness is pretty straightforward. I mean, we don't think it is normal to need a server that uses half a gigabyte of RAM just to run idle. We think that it should be possible to run a media server from very small devices. In fact, we even think that you should be able to run a media server from your cell phone if you want to. And we're working very hard to make sure that this becomes possible. Alright, so what did we do? How did we do this? We started a completely new server from scratch, and we kept in mind some very important design decisions. I'll go over the first three of these in more detail in the next few slides, but since I'm not covering the last two, I'll go over those two first. Well, as I explained before, the open and freeness helps maintain high security, high compliancy, all that, so that's pretty straightforward, I would say. And the dependencies is important because if you want to run on a embedded device, most libraries out there will only run on a desktop or server machine. They won't run on an embedded device. So we wanted to keep our dependencies down to a minimum so that it will run on anything you can throw at it. Basically, if there is a C++ compiler available for your platform, it will run. So that's very nice. Now I will go over the top 3 design decisions and explain why we did this and why we think it's important. Alright, so the modularity. We took modularity to an extreme. Most current media servers, they will run in a threaded mode, which means that they have one application, and for every task it needs to handle, it starts another thread. And a thread, of course, is something that can run on a processor separately from the rest, in case there are non-technical people here. Well, we did that slightly differently. We didn't just have a thread for every task. We have a whole process, a new program for every task. That means that every protocol we handle has its own application that we start separately from everything else. And not even that, but every connection that comes in starts its own application that handles just that one connection. And all these processes work together and make up the whole server. We also have a separate process for every stream source. We have 2 separate processes, one for live streams and one for on-demand streams. And there is one final process that does nothing more than monitor everything, track what is happening, start up new ones, control it, and that gathers the statistics from everything else, as well as other runtime information like memory usage, CPU usage, etc. Now the advantages this has is it creates a very robust application. The tasks are isolated from each other. They cannot influence each other. It's also possible to close a task and start it again without affecting the rest, which means you can do rolling updates. And being able to do rolling updates is something that's very important in an environment where you never want to turn your server off. It also creates a very fault-tolerant machine because, of course, we are aware that nobody writes flawless code. We like to say that we are better than everyone else, but of course, that is not something you can actually say or even check or anything. Everyone makes mistakes, so do we. And by making sure that our design is fault tolerant, that means that if there is a mistake, the effect of the mistake is reduced to a minimum. And additionally, the use of multiprocessing means that in this way, it means that we scale very well to the upcoming multiprocessing environments. Many machines right now no longer go up in speed, they go up in the amount of cores they have available. And we think that in the future, this really is a trend that will continue. And we think that more and more cores will become available. And most of the existing software is not suited for running on very many cores at the same time. Well, our software was designed with many cores in mind. In fact, every application very obviously scales to a processor. So in that regard, we think that we are ready for the future. So I'll go to the next advantage that we think we have, which is extensibility. Each of the processes that I mentioned in the last slide has a flag that lets it output in JSON format what it does. The capability information is what we call this. It explains to the controller or to a human or whoever wants to read it what this process does, how it does it, what information it needs to do it. So the main controller, it will, as it starts up, it will enumerate all the other processes that are available. It will ask them, hey, what do you do? How do you work? What do you need to do it? And it doesn't actually understand the inner workings of any of these processes, nor does it need to know them. All it needs to know is what they need to start and when they need to be started. This has a very clear advantage of the ability of adding new capabilities, for example, new protocols, without needing to modify any of the rest of the system. So you can write your own protocol handler application. You can put it in there with the rest of the server, and it will auto-detect it when it starts up, and it will automatically know how it works, what new URLs it services, etc. And you don't even need to touch any of our code if you want to add your own protocol. This is something that is very unique to our solution, and no one else can actually do this. Then we have the accessibility. We thought it was very important that you are able to get as much information from your server as possible. And I put some examples of our JSON-based API right here on the screen. It's not supposed to be readable, but I think that if you squint your eyes a little, you should be able to. Because we have so much information in there, it's very hard to show just a snapshot. I displayed 3 examples here. The leftmost one shows the capabilities and the configuration information that is exposed to the API. So this things as simple as how much memory is available in certain in all the areas, like how much cache is used, how much is free, how much web is in there. But it also makes an estimate of the processor speeds, how many threads are available, etc. The configuration is also done through this API, and that's the lower part of the left side. You can set what protocols you want enabled, what ports you want them enabled on, but you can even go so far as to say I want to run them under a different username on the system, or I want to run them on a different interface. And you can make as many copies of that in the configuration as you want, of course. The middle one shows off what happens when you configure a stream. Your own configuration is in there. It didn't actually fit in the screen, so it's not in there. But what it does after you configure it, it extracts the information from the file and displays it in this nice standardized format. So it doesn't care what format your movie is in, nor do your systems need to understand all the formats. All they need to know is how we report on these formats. And we support multiple tracks. As you can see, there's a track 1 and track 2 there. In this case, the top one is video and the top one is audio, and you can see there H.264 and AAC. But you can also add subtitle tracks. You can also add multiple video tracks in different qualities. All this is possible, and it will all be nicely reported through our API, so your system doesn't need to understand how all this works. All it needs to do is enumerate over the tracks and see what's in there. The last one shows how our logging system works, because we don't like log files. They're rather annoying to parse, they're hard to automate. So instead the API provides a big array of log messages with the times that they were triggered and what area of the server they are about. In this case they're all configuration messages, which means that these display what was changed in the configuration at certain times. You can see controllers starting up, you can see connectors being started, you can even see what settings are being used. And this is a pretty unprecedented level of detail in control and feedback from the server. So, after seeing all this, does it actually work as we intended it to work? Well, of course we think it does. I'd like to invite anyone watching or anyone interested to come by their booth right over there at 14.452. We have 5 different demos running right now and throughout the rest of the conference also. One of them is showing off that we can actually stream from a Raspberry Pi machine, and I noticed that someone else is actually showing that today also, so we're showing it first. One shows off exactly how our statistics works, how detailed it is, because these are up to the second accurate, even for viewers that are still connected and not even done watching yet. We show how we can deal with special metadata. In this case, our demo is about handling subtitles in different languages, even when the protocol, in this case, we're using Flash to display it. Flash does not support subtitles, well, we are able to display subtitles around Flash. We also have a simulation running that shows 25 different VOD streams being sopped through all on the same screen and shows the statistics next to it. We have another one that shows live DVR, where we have a minute worth of camera footage that is in every screen displayed with 2 seconds in between. Of course, if you don't believe our demos or you want to try something out yourself, you can definitely do that. We are open source after all. Our website has binary downloads for all major platforms and of course the source as well. Well, that was pretty much everything I had to say. If anyone has any questions, I would say ask them now or come by our booth later or just visit our website after all the conference is over.
Thank you, Sharon, for your early but brilliant presentation. Is there any questions in the audience? No questions? Thank you very much, Sharon.
All right, good.